In this presentation, we'll take a close look at the usBIM GeoTwin solution, one of ACCA Software's most recent development projects, combining BIM models and GIS data into a single, dynamically integrated platform. First, let's start with the term BIM methodology. ACCA Software, as many of you are aware, has developed tools specifically for the creation of digital models as part of the BIM methodology. To be specific, it is about constructing three-dimensional representations of physical and functional attributes associated with the construction industry, which are geometry, and all information related to the world of construction. All this, the BIM methodology, enables the integrated management of the artifact across its life cycle. On the other hand, the science of gathering, organizing, and evaluating geospatial data, or rather, geographical information typically displayed in maps, known as Geographic Information Systems, or GIS. We now have 3D scenes thanks to technological advancements. This is where the development of BIM technology comes into play, allowing us to incorporate information about specific structures into a 3D scene in addition to information relevant to spatial planning and management, allowing the two to work in tandem. In usBIM GeoTwin, for example, a platform-to-platform integration tool, ACCA has developed the usBIM platform, which includes all BIM data and models, while Esri has developed the ArcGIS online platform, which deals with all the GIS resources. Within an integrated platform that also enables data analysis from both worlds, all of this is accessible, navigable, and can be queried. Let's quickly take a moment to explain what the usBIM platform is. It's an integrated environment where the entire BIM process can be managed, including managing models in the Building Smart standard formats, such as IFC, instead of native ones, federating both BIM model geometries or simple geometric models like point clouds or textured meshes. It also includes collaboration tools like an instant messaging service and video meetings where the BIM data and models become the topic of discussion. It also allows data and document sharing through a system of articulated access permissions and information tracking pertaining to operations carried out within the platform. It's also customizable and allows you to build up a modular system to enhance your platform experience with all the features available in the usBIM Store webpage. Alongside this, there are a number of REST APIs for integrating with third-party software, connectors, and solutions that control this API call technology. Some of the connections were created by ACCA Software to address problems like facility management or IoT system monitoring. Using the usBIM platform ensures a unified work environment that can be easily shared with collaborators, suppliers, or healthcare services. It provides robust data security through cloud-based infrastructure powered by Amazon Web Services cloud technology, along with disaster recovery and backup systems to prevent data loss. As a cloud solution, your data is centralized and accessible from anywhere in the world, ensuring you always work with the latest information. The platform is compatible with all devices and operating systems, requiring only an internet browser to access its full range of features. The solution, developed by ACCA Software, supports the entire life cycle of the asset, from design through construction phases, including construction site and project management, to post-completion stages, facilitating asset management and maintenance. As mentioned, the platform is modular, enabling the combination of various modules to provide a wide range of functionalities. These include model coordination, visualization, model validation, public procurement management, construction oversight, and seamless integration between BIM and GIS platforms. To provide a comprehensive overview of the entire solution, it's important to highlight that the services offered include advanced visualization capabilities within the common data environment, as well as essential validation tools like clash detection and model checking. In addition to these, the platform offers access to online libraries and programming tools, enhancing flexibility and customization. All these features are designed to operate seamlessly with standard formats developed by Building Smart, including IDS and IFC, supporting all three official versions, 2.3, 4, and 4.3. Furthermore, the solution incorporates other widely recognized standards like BCF, enabling efficient collaborative workflows across teams and stakeholders. The platform enables seamless integration and connectivity with other systems through REST API connectors. As mentioned earlier, this includes compatibility with Esri's ArcGIS online platform, along with other functionalities previously discussed, such as facility management and the Internet of Things, IoT sector. Georeferencing, in essence, is the process of associating geometric data or objects with a geographic coordinate system. This begins with an internationally recognized dataset, such as the EPSG, which contains all cartographic reference systems. Additionally, there is a local coordinate system, typically used in engineering operations and design processes, as well as for defining artifacts. The transformation, or rather the translation of this local coordinate system to a geographic level, involves aligning the reference system onto a global scale. This process positions the local reference system on the globe, bringing along everything described within it. The platform's viewer is a powerful tool that allows the federation of multiple models of various types. For example, you can seamlessly combine and navigate through architectural, structural, and MEP models. It also enables the visualization and interrogation of all information linked to individual objects. This same immersive navigation experience is extended to the territorial context through usBIM GeoTwin. Here, you can observe the same residential complex, now georeferenced within its real-world context. The interaction remains consistent, allowing you to isolate and focus on specific aspects of the model, such as viewing only the structural or MEP components while excluding the architectural layer. You can interrogate individual entities within the model, enabling a journey from the microscopic scale, such as inspecting a single connector within the MEP system, to a macroscopic global scale. The platform also supports the visualization of large, complex models and scenarios. For instance, it can handle approximately 2,000 models representing the city of Barcelona. These models, while simplified, still carry critical information. Additionally, the platform allows for replacing basic volumetric models with more detailed and advanced models when needed. These detailed models enable interrogation of the structural, MEP, or other components of the federated models, providing a comprehensive overview at multiple levels of detail. In another example set in the historical city of Jadida in Morocco, we can see a slightly different scenario. Here, the city is represented as a textured mesh derived from a point cloud survey. This textured mesh is also available on the Esri platform, forming part of a separate database. Despite being part of a distinct database, the platform seamlessly integrates the textured mesh with BIM models. This enables interaction between the BIM models and the territorial base, allowing the same models to be accurately positioned and visualized within their geographic context. This integration highlights the platform's capability to bridge diverse datasets for enhanced spatial and contextual analysis. Let's move to another scenario that showcases the platform's impressive data processing capabilities. Here, we are visualizing a dataset comprising 2.6 billion points, representing the detailed survey of the iconic Siro Stadium in Milan. This example highlights the system's ability to handle and process massive point cloud datasets with precision, enabling detailed analysis and exploration of complex structures at an unparalleled scale. The platform also offers the ability to interact between different contexts, such as the territorial context and the BIM model. For instance, you can take precise measurements between these two contexts, or create sections to visualize the level of detail achievable within the BIM models. This capability can be explored not only through standard tools, but also using advanced technologies like virtual reality. In this scenario, we're looking at the ACCA headquarters, which is a federated model combining architectural and MEP components. You can easily toggle between different models. focusing on specific aspects like the architectural or MEP components. Moreover, this experience extends into augmented reality, where using a headset, the model can be visualized in the real world, combined with relevant information. This allows users to directly interact with the model, such as viewing the layout of systems or accessing specific details related to individual objects, making the model not just a visual representation, but an interactive tool for in-depth analysis. Let's return to the same scenario to demonstrate how models can evolve over time. In this case, we're still looking at the same complex we saw earlier, but now the federation is updated. Within the viewer that manages our federations, we can add a new building at the base of the existing structure. As soon as the new building is added, the viewer automatically updates to reflect the change, and you can immediately see the GIS environment is dynamically updated as well. This ensures that all data is always current and available to anyone who needs it. From this point, we can activate features in the GIS environment that integrate 2D territorial data, allowing it to interact with the 3D BIM models. This integration provides a comprehensive view, blending geographic and model-based data for enhanced analysis. Moreover, the platform offers a powerful use case for asset and facility management, which can be activated through connectors. For example, we see a management center where various assets and environments are listed. Users can select a specific object within the model and query it for details like its properties, maintenance tickets, or scheduled activities. This functionality enables real-time asset tracking, making facility management more efficient and effective. It's also possible to view the planned activities for a specific object, essentially creating a checklist of all operations scheduled for the asset. Additionally, you can directly access a ticket from the BIM model, which is associated with an upcoming intervention or maintenance task on that particular asset. Now, let's move to another location with a different use case. This is a federation of approximately 56 IFC models that form the Naples Central Station, designed by the Miniti engineering firm. Within this federation, you can navigate through the model and select any individual object. Upon selection, the associated information is easily accessible, whether it's in the form of PDF documents or images related to the installed asset. This level of integration provides a comprehensive view of both the model and its documentation, making it easier to manage and maintain the asset. Let's move on to another important topic: infrastructure monitoring. In this example, we see the structural model of a bridge equipped with a series of sensors. The platform, through its available connectors, allows you to visualize sensor data using a color-coded system that provides immediate feedback on the state of individual elements. For instance, you can activate a color scheme to highlight when a sensor has detected values that exceed preset thresholds, making it easy to spot potential issues. Additionally, you can set up alarms that notify you if danger thresholds are reached, allowing for proactive management and maintenance. The platform also supports the management of models compliant with the latest IFC 4.3 standard, which was specifically designed for linear infrastructures. In this example, we see infrastructure elements like roads and tunnels integrated within their territorial context. This feature makes it simple to visualize how these linear infrastructures are situated and interact with their surrounding environment, ensuring accurate representation and management. ACCA Software has always been actively involved in the Building Smart initiatives, supporting the development of new standards, and has even provided an example of a tunnel model that may become part of a future version of the IFC schema. Continuing on the topic of the latest version of the IFC standard, here we see another example: a model created with IFC 4.3, which can be navigated in virtual reality. This immersive experience allows users to explore a territorial context and interact with the positioning of an artifact, providing a more intuitive understanding of its spatial arrangement. Furthermore, ACCA has conducted advanced experimentation and provided solutions in various sectors, including energy. In collaboration with a leading player in the energy market, ACCA demonstrated the capability to federate surveys, such as point clouds along a railway line, and integrate BIM models derived from these point clouds to enrich the navigation experience. The platform also allows users to access different scenarios, such as work planning. For instance, you can view a construction timeline interactively, which gives insights into the progress of the project. Additionally, when point clouds are linked to BIM models and supplemented with 360-degree photos, users can activate dynamic navigation. This allows for synchronized viewing of both the model and the 360-degree photos, providing an integrated perspective that combines both geometric data and documentary information. This dynamic integration enhances the way users engage with both visual and data-driven aspects of the project, ensuring that all relevant information is easily accessible. The platform can also be utilized for managing processes related to issuing permits and licenses, integrating seamlessly with urban planning systems. This feature enhances collaboration by enabling efficient coordination between various stakeholders. For collaborative work, the platform allows multiple users to connect remotely within the same scene. In this example, 4 users are browsing the model from different points of view. One of the users can activate the synchronization of their view with the others, ensuring that all participants are navigating the model together. This synchronization makes it easier to guide the team through the model and facilitates productive discussions, as everyone is focused on the same scene at the same time. This collaborative capability is especially valuable for project coordination and decision-making, as it ensures that all parties are on the same page during model reviews or discussions. Another useful feature of the platform is the visibility of avatars representing the various users connected to the same model. This allows everyone to quickly identify who is currently working on the model, as you can see the avatar of each user in the scene, enhancing collaboration and communication. The platform also supports the modification of IFC files using tools such as BIM Editor, developed by ACCA Software. In this example, we can see the modification of an object within an IFC model. These changes are reflected dynamically and in real time on the scenes currently being viewed by other users connected to the same model. This live updating ensures that everyone is always working with the most current version of the model, promoting a smoother, more efficient collaboration. Additionally, when a new entity is inserted into the model from an online library, all users connected to the scene can immediately see the update. This real-time visibility of modifications and additions ensures that every participant is on the same page and can quickly adjust their workflow as needed. Let's now explore the integration of BIM data with GIS data. In this example, the data from the BIM model have been exported and linked to the objects within the model, enabling the creation of spatial analyses on the Esri platform. Here, we can see a scenario where certain objects, such as windows and boilers, have been selected. Through spatial selection, which in this case is done manually, but can also be achieved through automated intersection with other GIS functions, we are able to identify and select all objects within a specific area, such as boilers or windows. Additionally, the platform allows us to display all the relevant information associated with these selected objects. This integration enables powerful spatial analysis and the ability to query and visualize BIM data in the context of geographic information systems, enhancing decision-making and planning capabilities. The ability to connect GIS data with BIM data enhances the platform's functionality, while still maintaining the capacity for traditional synthetic visualizations. For instance, users can visualize intended uses of spaces and easily access associated documentation for individual objects, making it simpler to query and manage critical information. In addition, ACCA Software has made significant strides in integrating artificial intelligence into its platform. With the use of generative language models, such as BIM GPT, users can now interact with their models in a more intuitive and automated way. For example, you can ask BIM GPT about the specific entities present in the model, and it will provide a detailed list of all the objects. You can inquire about the intended uses of different environments within the model and receive clear contextual responses. Furthermore, you can request graphical representations, such as graphs showing the distribution of incidences based on intended uses, allowing you to gain immediate insights into the project's layout and planned operations. This AI-driven capability makes navigating and managing complex models faster and more efficient. You can also use the system to make more specific queries, such as selecting a particular type of space, like bathrooms or rooms, within the model. For example, you might ask the platform to identify the largest bathroom and receive both the selection and relevant data, such as its surface area. This ability to ask detailed, context-specific questions and instantly retrieve accurate data greatly enhances the utility of the model. The integration of BIM data with GIS data offers a powerful advantage by enabling these two distinct domains, each focused on data management and spatial organization, to work together seamlessly. By leveraging the strengths of both, we aim to make this combined functionality available in a way that is straightforward and intuitive for all users, streamlining workflows and ensuring that critical information is always at hand. This approach maximizes the potential of both BIM and GIS, making them more accessible and easier to work with in tandem.